In this tutorial, we'll learn about Git, a widely used version control system that helps developers track changes in their code, collaborate with others, and manage different versions of a project over time. Version control allows you to keep a history of your work, revert to previous states if something goes wrong, and work on new features without affecting the main code base. Git makes collaboration easier by enabling multiple developers to work on the same project simultaneously, merge their changes, and resolve conflicts efficiently. By the end of this tutorial, you'll understand the core concepts of Git and how to use it in your development workflow. The first step in working with Git is setting up a repository, which is where your project's version history will be stored. If you are starting a brand new project, you use Git init to initialize an empty Git repository in your current folder. This creates a hidden Git directory that starts tracking changes in your project. On the other hand, if you want to work on an existing project that is already hosted remotely, for example on GitHub, you use git clone URL to download a full copy of that repository to your local machine, including its entire history and files. The basic Git workflow revolves around tracking changes, staging them, committing them to your local repository, and syncing with a remote repository. When you run git status, it shows you what has changed in your working directory, such as modified, added, or deleted files, so you know what needs attention. To prepare changes for a commit, you use git add. To stage all modified files at once, or git add file if you only want to include a specific file. Staging acts like a checkpoint where you decide exactly what will go into your next commit. Once your changes are staged, git commit MMSG saves them as a snapshot in your local repository, along with a message describing what you changed. This helps maintain a clear project history. After committing locally, Git push uploads your commits to a remote repository, like GitHub, making them available to others. On the other hand, Git pull fetches the latest changes from the remote repository and merges them into your local project, ensuring your code stays up to date with the rest of the team. Branching in Git allows you to work on different features or fixes independently without affecting the main code base. When you run git branch, Git shows you a list of all available branches in your repository and highlights the one you are currently on. To create a new branch, you use git branch name, which creates a separate line of development where you can safely make changes. To move between branches, you use git checkout name, which switches your working directory to that branch. A quicker way to both create and switch to a new branch is git checkout b name, which combines both actions in one step. Once your work on a branch is complete, you can integrate it back into another branch, usually the main branch, using git merge branch, which combines the changes from one branch into your current branch. These git commands help you inspect and stay updated with the state of your project. When you run git fetch, Git downloads the latest changes from the remote repository, like GitHub, but does not automatically merge them into your current branch. This allows you to safely review updates before integrating them into your local code. The command git log shows the commit history of your repository, listing past commits along with their messages, authors, and timestamps. It helps you understand how the project has evolved over time and trace changes when needed. Finally, git diff is used to display the differences between files or commits. It shows exactly what has been added, removed, or modified in your code, making it useful for reviewing changes before committing or merging. These git commands are used when you need to undo changes or correct mistakes during development. When you run git reset file, it removes the specified file from the staging area, meaning it will no longer be included in your next commit, but your actual file changes remain untouched in your working directory. This is useful when you accidentally staged something you didn't intend to commit. The command git checkout file discards all local changes in that file and restores it to the last committed version. This is a destructive action because any uncommitted changes in that file will be lost. Finally, git revert commit creates a new commit that reverses the changes made by a previous commit. Unlike reset, it does not rewrite history, which makes it safe to use in shared repositories where other people may already have pulled the commits. These git commands are useful when you need to temporarily set aside work, restore it later, or clean up unwanted files in your project. When you run git stash, Git temporarily saves your uncommitted changes and clears them from your working directory. This is helpful when you need to quickly switch branches or pull updates without committing unfinished work. Your changes are safely stored in a hidden stash stack. The command git stash pop restores the most recently stashed changes back into your working directory and removes them from the stash list. This lets you continue working exactly where you left off. Finally, git cleanf removes untracked files from your project directory. These are files that are not being tracked by Git, not staged or committed. It is a powerful command, so it should be used carefully because deleted files cannot be recovered through Git once removed. You've successfully completed the Git basics. At this point, you should understand how to create and clone repositories, track changes, stage and commit work, manage branches, and sync with remote repositories. You've also learned how to inspect history, compare changes, and safely undo or clean up work when needed. With these fundamentals, you now have a solid foundation for using Git in real-world development workflows and collaborating effectively with other developers.